Today I'll solve one numerical problem on PdVWork in various quasi-static process. So here is a problem statement. A gas in a piston cylinder undergoes an expansion from initial pressure, that is 3 bar, and initial volume 0.5 meter cube to a final volume of 1 meter cube. During the expansion process, the relationship between pressure and volume is given by PV to the power n is equal to constant, means it is a polytropic process. Determine the work obtained for different values of n, means if n is 1.5 then it will be polytropic process, n is equal to 1, so that is PV is equal to constant and n is equal to 0. Now I have to calculate what will be the work obtained for different values of n. So when n is equal to 1.5, n is equal to 1 and n equal to 0. Now first, what is the theory behind it? So first we have to calculate the work done, means so here P v to the power n is equal to c. So the given equation is P v to the power n is equal to, we can write P1 v1 to the power n is equal to P2 v to the power n is equal to constant. So this equation implies P is nothing but P1 v1 to the power n by v to the power n, or P is equal to P2 into v2 to the power n by v to the power n. So that we can write from here to here. Now work for the process state 1 to state 2, so we can write so work done from state 1 to state 2, so integration of v1 v2 PdV. Now for this case actually n is equal to infinity. If n is equal to infinity, so we have P v to the power n equal to c is as a constant, so v infinity represent the constant volume. So when that volume is constant, so when v is raised to the power infinity, it implies the volume held is constant throughout the process. So if volume constant means there is no work. So now for n is equal to 1, if n is equal to 1, the work equation simplifies to that state 1 to 2, so integration of v1 v2 p1 dv, so p1 v2 minus v1, we can write that. So n is equal to 1, so work done is p1 into v2 minus v1. Now if that n not is equal to 1, so then we can write p or w12 is equal to integration of v1 v2 p1 v1 to the power n by vn dv. So now here, okay, so first we know that here p into dv, so we can replace p p1 v1 to the power n vn. Now if I do the integration, so we will get that v2 1 minus n p1 v1 to the power n v2 1 minus n minus v1 1 minus n and 1 by 1 minus n. So now if I simplify, or we can, if I do that p dot vn is equal to p1 v1 per n or p2 dot v2 per n constant, so ultimately we'll get that work done from state 1 to state 2 p2 v2 minus p1 v1 by 1 minus n. So here we can write, this is the equation. So if I put different n value, and if I know that p2 v2 and p1 v1, we can easily calculate what will be the work done. Now from the problem, first problem number 1, so n is equal to 1.5, so p v to the power n is equal to constant. So here we know that w is equal to p2 into v2 minus p1 v1 by 1 minus n. So now that p1 and v1 is given, so now we have to calculate. So p1 v1 to the power n is equal to p2 dot v2 to the power n is equal to c. So from that we can easily calculate p2 is p1 v1 to the power n by v2 to the power n. So we have all this data. So n is 1.5, ultimately p2 is 1.0607 into 10 to the power minus Pascal. Now if we plug all this value, find w. So ultimately if I plug that p final v initial minus v initial by 1 minus n, so ultimately w will be 87860 joule. So now when n is equal to 1.5, that work done is 87860 joule. Now when n is equal to 1, n is equal to 1 is nothing but PdV, okay, v2 by integration of v1 minus v2, so PdV, okay. So from that, okay, so here we got n is equal to 1 dV, so that v1 v1 here there is something wrong, I hope so. So from that here, that when n is equal to 1, so that is W is equal to V1 V2 PdV. So we can change that P, so that is P1 V1 by V. So we'll get that P1 V1 ln P1 by P2. Okay, so and nRT ln V2 by V1. So everything we have, so we have to calculate the W. So if I plug, so W will be 1.04 kilojoule. And then finally, if n is equal to 0, so n is equal to 0, that P is actually constant, so work done per mole is nothing but W, P initial minus V final minus V initial. So from that, if we plug all this value, W will be 150 kilojoule. That's it. So now one rectification. So this is, I think it should be that not PdV. Okay, not P1, something like that. So PdV. So from that we have to take that P1 V1 by V2 into dV, and then we have to do that. So this is not correct. This is not correct actually. That's it. So we'll get the different value of so here when n is equal to 1, so we'll get W is equal to 1.04 kilojoule.